Today we will go over the slope of parallel and perpendicular lines. So here we go. How can we tell if lines are parallel based on the equation? If we're looking at the equation of the line, y equals mx plus b, it needs to have one, same slope, and two, we need to have a different y-intercept. So in my equation of y equals mx plus b, m right here is my slope, and b over here is my y-intercept. So really there's only two criteria that we have to look for. Same slope and different y-intercept. So if two lines are parallel, then their slope has to be the same. Slope is the m, must be the same. For example, y equals 2x plus 8. And y equals, because I want parallel lines, it should also have 2x. But now my y-intercept should be different. So instead of plus 8, it can be plus 5, or minus 1, or minus 8. Something different than plus 8. Okay. On a graph, here's how we can check for parallel slopes. Slope is also called, referred to as rise over run. So on my graph, from one point to the next point, we need to count. We can count. How far did I go up, and how far did I go over? That's up 2 over 3. Compared with your other line, my other line went up 1, 2 over 1, 2, 3. So they have the same slope. That makes them parallel. So let me go ahead and write the equations down. So again, my equation of my line over here, y equals mx plus b. My slope is 2 over 3, rise over run, so 2 goes on top, over 3x plus b. The y-intercept is where my line crosses the y-axis, x-axis, y-axis. So on the y-axis, I cross up here, which counting from the origin, that's 1, 2, 3, 4, 5, 6, 7. So y equals 2/3 x plus 7. Now let's do the same thing for the other line. My slope is 2 over 3, rise over run, 2/3, plus, from my origin, I went up 1, so plus 1. Now if we don't have a graph on which we can count, there's also a formula for slope. Slope formula is y2 minus y1 over x2 minus x1. And sometimes you may hear it referred to as delta y over delta x. So that's how we find slope. So look at my equations over here. Let's find the slope of the following lines. Again, slope is the number in front of your x. So in this case, the number in front of my x is 3, slope is 3. Do note that this only works for y equals mx plus b. It needs to be in this format. It needs to be in y equals. If we don't have y equals, this will not work. You have to get it into y equals first. So over here, notice my slope and my y-intercept are switched. So we're focusing on the slope, the number with the x. That's a -2. Again, there should be parentheses there. We're focusing on the slope, the number in front of the x. That's a -2/3. So now I'm just going to show a couple different examples of parallel lines. If I want a line that's parallel to y equals negative 3x plus 5. That means I want to keep the slope of negative 3x, but now I want a different y-intercept. So instead of plus 5, let's pick minus 5. Another example, for y equals 7x minus 2, we have to keep the slope y equals 7x, but instead of minus 2, it can be plus 1, a different y-intercept. And lastly, y equals 1 half x plus 4. So let's have instead 1 half x, I don't know, plus 9. Okay. So next, are these lines parallel? Again, for parallel lines, we need to check the slope. However, my equations are not in y equals mx plus b form. So let's go ahead and get them into y mx plus b form, so that we can compare the m and the b properly. So equation over here, we have 10 equals 2y plus 6x. Notice equals means the left and the right are the same. And normally, it's easier for us to have y on the left side, because that's how we're used to seeing it. So I'm going to go ahead and swap the two sides of the equal sign. So instead of 10 equals 2y plus 6x, I just switch the two sides of the equal sign to make it 2y plus 6x equals 10. It's equal, we can do that. So now I want to solve for y, get y by itself, isolate y. So I want to get rid of everything around the y. First thing I want to cancel is that 6x. On the left side, I'm left with 2y. 6x cancels out. Equals, again, we have y equals mx plus b. Normally, we write the x first. So I'm going to write the x portion first, negative 6x plus 10. And I would like to stress out that please write down the x. That's a negative 6x. Reason I want to stress that x out is this 10 and this x are not like terms. Over here does not have an x. Over here it does have an x. So one has x, one does not. We cannot combine them. So I don't want to see 10 minus 6 equals 4. It doesn't work that way. Alright? Keep the x with the constant, the number, separate. And last step, we have 2 times y equals negative 6x plus 10. Opposite of 2 times y, we divide by 2. When we divide, we have to divide every single number. And that gets us y equals negative 3x plus 5. So if you'd like to pause this video and work out the right side, the right equation on your own, I highly suggest on doing that. Otherwise, I will just keep on working on the right side. Alright, so if you tried solving it on your own, the answer you hopefully should have gotten is y equals negative 3x plus 5. Notice my two equations are exactly the same. So this is what we mean by we want to have the same slope but a different y-intercept. Well, this y-intercept and that y-intercept. Because if my slope and my y-intercept are exactly the same, then graphically this is what's going to look like. Here's my first line, and my second line, since it's the same, it's going to go right on top of it. So we have two lines on top of each other. And again, our definition of parallel is they do not intersect. But two lines on top of each other, the exact same line, will intersect. They're intersecting everywhere. So, because even though they have the same slope, they both have a slope of -3, because they also have the same y-intercept, meaning this y-intercept and this y-intercept are not different. We have the exact same line, they are not parallel. Okay. So now let's move on to perpendicular lines. For perpendicular lines, I know I have all these blanks, but really, there's only one important criteria we have to look at, and that is slope. Slope should be opposite reciprocals of each other. Opposite reciprocals. And I'll go and make an example first. Y equals 2/3 x plus 1, and y equals -3/2 x, I don't know, minus 5. Okay. So, look at the slope. Pause this video for a minute and look at the slope, and see if you can think of any similarities or differences between them. Alright? If you'd notice, the numbers are almost the same. We have a 2 and a 3 and a 2 and a 3. The only difference is the fraction was flipped. Fraction was flipped. And also the sign. One is positive, one is negative. So what we mean by opposite reciprocal is, reciprocal means that the fraction is flipped. And over here, let's go ahead and add by opposite, we mean switch signs. So they are perpendicular lines have opposite reciprocal slopes. So let's do an example. My fraction here is 3/4. Opposite reciprocal, I flip the fraction, so 3/4 becomes 4/3. 3/4 is positive, so the opposite would be negative. So pause this video and spend about a minute solving the rest of these. Alright, so you should have gotten 10/7. 13 as a whole number. This is a whole number. As a fraction, that's really a 13/1. So when you flip 1/13, -1/13. Likewise, this is -3/1. So when you flip the fraction 1/3 and change the sign, positive 1/3. So putting everything we've learned together, let's determine if the following lines are parallel, perpendicular, or neither. Number 1, compare the slopes of the two lines. Slopes are the same, and the y-intercept are different. That makes it parallel. And I'll be lazy, so I'll just use symbols here. Parallel. Okay, there's a parallel symbol. This is the perpendicular symbol. Number 2, compare the slopes. My slopes are not the same, so they are definitely not parallel. So let's check to see if they're perpendicular. -4, if I flip my fraction, is 1/4, and negative became positive. So it is an opposite reciprocal. That makes it perpendicular. Next one, we have a -4 and a -1/4. My fraction did flip. 4/1 flipped to become 1/4, but they have the same sign, so they cannot be perpendicular. This is neither. And last one, both of them have -4 as the slope, so slope's the same. Let's check if they're parallel. One has a plus 3 for y-intercept, the other one has a minus 3. Yes, they're both 3, but plus 3 is different from minus 3. So they still have different y-intercepts. That makes them parallel. Right? And last part I'd like to talk about is this box over here. What would be the slope of a line parallel to a line with an undefined slope? An undefined slope is a vertical line. So quickly drawing a sketch of a graph. That's a undefined slope. The line's completely vertical. So if I want a slope to be parallel to it, it needs to have the same slope. It also needs to have an undefined slope. And the equation of a vertical line looks like x equals c, where c is a constant. C can be any number. So x equals a number. It's an undefined slope. What about a line perpendicular to it? So if one line is completely vertical, then the line perpendicular to it has to be horizontal to form that 90 degrees. Horizontal line. A horizontal line is like a flat line. Flat line meaning zero slope. And a line with a zero slope has an equation y equals c. Again, c means constant, c means any number. So y equals just a number without any x is a zero slope. So there you have using slope to determine if lines are parallel or perpendicular.